Hey guys, welcome back to Zilliqa Zebra. Zilliqa is introducing a new and improved NFT token standard that will drive Zilliqa right into the forefront of the creator economy. The ZRC-6 is a major upgrade from the ZRC-1 and includes several novel features that will be key for creators and builders. This standard also includes some enhanced functionalities for NFTs powered by Zilliqa. In addition to being energy friendly, ZRC-6 will pave the way for Zilliqa as a leading NFT issuance platform. Zilliqa is opening things up for community feedback as they finalize the standard. Here are some of the key features of ZRC-6. Number 1 is royalties. Marketplaces cannot integrate royalty features with ZRC-6 tokens, as the tokens allow for an optimal interface that capture royalty details, enabling creators to be paid royalties on sales. Number 2, batch operations for minting, burning, and token transfers. The delivery of all these innovative features is the core of Zilliqa's ambitions to become the blockchain of choice for the creator economy. In this video, I will be running through the impetus for adopting the ZRC-6 standard, as well as some of the features of ZRC-6. This is rather technical, so pardon me if my video is not able to convey the features in the best way possible. As always, don't forget to like and subscribe to Zilliqa Zebra for all things related to Zilliqa and its ecosystem. Over the past year, Zilliqa has had a front row seat to the evolution of non-fungible tokens and the advent of the creator economy. COVID-19 disrupted most industries and crypto was no exception. When the market went parabolic, the Zilliqa team saw emergence of new value-driven models, revitalized fan engagement, and new monetization opportunities for talent powered by blockchain. Let's recap for a moment. Early on, Zilliqa identified the value proposition of NFT marketplace and have onboarded Mintable to the first Zilhive Accelerator program in 2019. Mintable has since grown into a vibrant multi-chain NFT marketplace, attracting investors such as Mark Cuban. Later, Zilliqa supported numerous NFT marketplaces and play-to-earn NFT domains like the Bear Market, Demons, Non-Fungible Duck, and Unicubes, who are also finding tremendous success. Having also built up proprietary platform Zilstars, Zilliqa led bespoke NFT projects with athletes and sports personalities and artists. Now, Zilliqa wants to take this to the next level by creating something truly experiential and rewarding for all. Today, they are doing just that with a multi-million-dollar NFT projects in the works. Stay tuned. They are also implementing a creator fund, which will commission physical and digital works from artists. Curated by a panel of carefully chosen experts, the fund will collect and invest in amazing NFTs to deploy on Zilliqa. The potential, financially and creatively, is tremendous. By developing such platforms, they are aimed in large part at enhancing accountability, provenance, intellectual property, royalties, and traditional business models. The Zilliqa team wanted to be technically ready to deliver for the platforms, projects, and partners. To serve this goal, Zilliqa plans to move from ZRC-1, the specification for current NFT standard used since November 2019, to the newly designed standard ZRC-6. This standard will serve Zilliqa's ambitions of becoming the top Layer 1 protocol to power NFTs, the metaverse, and all things creator economy. The Zilliqa team believes ZRC-6 to be better than what's offered on the Ethereum platform because number 1, NFT standards in Ethereum are fragmented. This leads to slow adoption of innovative features proposed on newer standards. 2, individual standards on their own lack specific useful functionalities, for example, batch operations such as minting, burning, and token transfers. 3, certain contract states cannot be read by other contracts. For instance, under the official ERC-721 standard, it's not possible to retrieve a list of token IDs owned by a given holder. Such capabilities need to be added on top of specifications, for example, Open Zeppelin implementation. In ZRC-6, Zilliqa consolidates innovative features and best practices. This includes 1, consolidate multiple innovative features such as royalty and batch operations into a single easy-to-use standard. 2, promotes the use of newer Scalar language feature to optimize contract sales. Attention for all marketplace builders, NFT project teams, and community members. The Zilliqa team is now opening this specification for public review starting from today till 13th of December 2021. You can discuss or provide any valuable feedback at their GitHub discussion page at the link below. They are aimed to finalize this specification shortly after the public review phase is completed. First, let's note that ZRC-1 will still remain as the NFT standard. For existing projects that are using ZRC-1 specification, there's no need for migration to ZRC-6. It's perfectly fine to continue using ZRC-1. The Zilliqa team does encourage new projects to adopt ZRC-6 once it's finalized. Let's now take a look at some of the existing limitations which inspired the team to create the new ZRC-6 standard. 1. No interfaces to support royalty payments, batch operations, admin ownership transfer, and emergency pause. 2. Standard was developed before the existence of Scalar remote state read feature. As such, there was usage of many callback patterns which were not user-friendly. 3. Callback interface is the same as ZRC2, hereby making it hard to compose ZRC1 and ZRC2 tokens. 4. Token URI interface and transfer operations are not optimized. The first feature to note is the royalty information retrieval. Many of the largest NFT marketplaces have implemented incompatible royalty payment solutions, as ZRC1 does not specify any interfaces to capture royalty details. In ZRC6, you'll be able to implement an optional interface that captures the following information. 1. Royalty recipient address. 2. Royalty fees basis points, example, 1000 equals to 10%. A marketplace that wishes to integrate with ZRC6 royalty features can then use remote state read to read this value and compute the royalty amount and send it over to the royalty recipient address. The computation will simply be this. Royalty amount equals to sale price divided by bracket 10,000 divided by royalty fees BPS close bracket. By making the marketplace aware of the royalty fees and recipient address, the marketplace or royalty owner can choose to go a step further to implement more innovative features around the royalty scheme, such as 1. Conditional royalty. For instance, royalty payment will only be made after a certain condition is fulfilled. For example, transaction price is above a certain price or exceeds a certain volume. 2. Dynamic royalty. Over time, the received royalty is a function of the original fee's value, thereby reducing or increasing the royalty amount received over time. 3. Royalty DAO. A DAO that receives all the royalty fees and is governed by token holders. The second feature is the token URI. A token URI is a HTTP or IPFS URL that hosts the metadata of the NFT. The metadata is simply a JSON block of data, which can be easily parsed by any front end. All metadata about an NFT must be in a JSON file. The token URI is split into two parts, base URL and token ID. ZRC-6 standardizes token URI with the concatenation of base token URI and token ID. Next feature is remote state read. Starting from Zilliqa version 8.0.0, Zilliqa has added a new feature, remote state read. This allows for easy reading of another contract's mutable variables. As such, the team will be reducing the number of callbacks as opposed to what we have in ZRC1 and promote the use of remote state read instead. To understand how the whole process is optimized in ZRC6, let's look at the previous callback-centric model in ZRC1. In order to retrieve another contract state variable, 1. The initiating contract initiates a call to a target contract transition. 2. The target contract will retrieve the variable and return it by calling another transition on the initiating contract that will accept the return value. For example, token balance of user. 3. The initiator contract will then need to process the return data in transition that receives the data. As you can see, the main disadvantage of this approach is that you will require 2 contract calls and 3 transitions. This is a very cumbersome process. With remote state read, this whole process is now optimized to 1. The originating contract use remote state read to read another contract mutable variables. 2. The originating contract process the return value in the same transitions. In this model, it only requires 1 remote state read and 1 transition. This approach reduces the complexity of smart contract logic and gas consumption costs in ZRC-6. The fourth feature is Pausable. One of the recommended best practices by consensus is to prepare for failures such as smart contract bugs. A recommendation was to provide a circuit breaker, such as pausing the smart contract, and provide an upgrade path for resolution of such situations. In ZRC-6, Zilliqa provides optional transition interfaces for pausing and unpausing the contract. When the contract is paused, minting, burning, and token transfers will not be permitted. This will allow the contract owner to pause critical operations and identify and implement a resolution for the issue in concern. The fifth feature is batch operations. In ERC-721 and ZRC-1, one major limitation is the lack of batch operations interface. Such interfaces can provide a better user experience. For instance, imagine a metaverse or a blockchain game in which you wish to buy a mana potion. You will want to buy and mint such potions in bulk to save time and gas. Similarly, peer-to-peer trading of NFTs can also be made more efficient. One such implementation can be found in ZRC-1155, which is proposed by the Engine team. In ZRC-6, Zilliqa has added optional batch operations transition interfaces for minting, burning, and token transfers. Such operations will definitely go a long way in improving the user experience in the Zilliqa ecosystem and help provide gas savings for the users. The sixth feature is a single transition for token transfers with destination validation. ZRC1 includes transfer and transfer from for the token transfer. The two transitions have the same type signature, and the only difference is the access control. This has added unnecessary complexity. Further, ZRC1 does not validate the destination for token transfer. ZRC6 features a single transition for token transfer with destination validation. The transition can be called by a token owner, a spender, or an operator. ZRC6 prevents transferring tokens to the zero address or the address of a ZRC6 contract. The last feature is ZRC-X compatible. Currently, ZRC1 and ZRC2 specifications share the same callback names. This creates a composability issue when the contract wishes to interact with both ZRC1 and ZRC2 tokens. In ZRC6, we resolve this composability issue by prefixing ZRC6_ for all callback transitions. ZRC6 will be highly welcome to bring together the future that the Zilliqa team is building. While the team is working on standardized token URI, there is no standard for metadata structure. They are currently working on ZRC-7 to formalize the structure of metadata. This will be a vital step for the team to expand the NFT offerings and composability on Zilliqa as they embrace the creator economy and get closer to the metaverse. I hope you have found this review useful. Don't forget to subscribe to my channel for a regular dose of Zilliqa and cryptocurrency news. And check out my other videos which might be of interest to you. Goodbye.